Welcome back to the shrine for the hand-me-downs of the industry, where ancient industrial tools and equipment come to get a new life. Today we got a new project you're not gonna believe, but I built another cam scanner, and this was necessary because the first one didn't give me the results I was after. You might remember there's a previous video in the description where I built this cam scanner, and in that cam scanner I can go and rotate the camshaft degree by degree, let's say, and figure out how much lift we're gonna get from the cam lobes. Well, the scan came out alright. The problem with the scan was that there are a bunch of other parts in the assembly and everything has tolerances. So first of all, here is the cylinder head. You know, there are positions of these holes relative to the combustion chamber, relative to the valves. There's a length to the valves. Also, the valves have a lock system, probably familiar with. So there's a valve and there are these two locks. Okay, so the little locks go in like so, and then there's this spring retainer that basically wedges in, and everything has tolerances. So when you put the whole thing together, then it's gonna have a large spread as far as dimensions. So I realized that, and I didn't like the numbers, so I decided to go back and maybe come up with a better system. In this case, what I decided to do is to go and assemble an indicator right at the valve and measure the valve lift directly. So I'm turning the shaft here with a specific rate, and in the same time I can measure the valve lift. So let's see how it works. So I made a bracket, and the bracket has a countersink here, and there's a precise bushing here that is ground on the LD, so it's got a nice diameter. And it happens that the housing has the same kind of countersink here. You can see these two will mate nicely. So there's a long bolt, and of course I'm using spacers as I can find in my workshop, and so just like that I can install it, and then I can make sure that it's parallel, and it's parallel, for example, to this edge here, because there's a little wiggle room, and I can tighten these up like so. And basically I have an instant bracket that will be able to hold the indicator. So here's the indicator. I've used it before, you've seen it. I have a little bracket I made for one of the projects. This still works just fine. So that bracket goes in here. In this case we're going to be looking at the exhaust valve that goes like that, and now I can install the indicator. So something like that. Tighten up. There you go. So now you can see if my exhaust valve is moving, the indicator is moving, and I'm just moving the exhaust valve with my finger. Now I can do that because I only have the inside springs installed. When I was doing this whole layout, I did some calculations, and it turned out I need about 2.5 Newton meters of torque, and this motor with the gearbox would be able to provide that. But when I was testing it, every once in a while it wasn't able to turn it over. So what I ended up doing is I basically removed the outside springs. You can see on both sides, the inside spring provides a little less force, but nonetheless you can see that I can move it with my finger, and it moves the indicator. So the indicator is gonna precisely pick up the movement of that valve. Now, one thing I realized here is I spoke about this decompressor cam here many times. Some people call it decompressor cam. What I found is that if this decompressor cam is not aligned properly, then the rocker arm, instead of rolling on the exhaust lobe, it is going to roll on this decompressor lobe. And I believe that's done on purpose that way. Again, I didn't analyze it, but if I set it up this way so that this finger is right between the two lobes, you know, aligned in this plane, then it's going to work properly. So the next thing now is this coupler. It bolts up to the camshaft with these 3 bolts, like that. I don't need to tighten it up too much, just basically do it finger tight, sort of finger tight, a little bit more than finger tight. And then there's a bolt here, and that will mate with this flat, so that gives a perfect position for that. And I'm not going to tighten this up for the time being, just going to leave it like that. So what I want to do is when I assemble this, I want this to move axially a little bit. So once it's installed and I made sure that this finger is in the right position, then I can install this like so. Okay. So you can see it goes in nicely. And now I can go and install these bolts. So there are 2 bolts that will retain the motor flange relative, this motor flange relative to the cylinder head. And right here on this side I have a marking of the center line of the cylinder head, and I'm just trying to eyeball it so that it's between this opening here. So you can see there's an oval opening. So that's going to be my 0 mark, sort of a starting point for the scanning process. It's a blind assembly, so it's kind of hard to match all the parts in, and there's not much clearance inside. If you look at the CAD model, you can see that there's not much clearance. So now I can go find the screw right there and tighten it up so it locks up the camshaft to the motor shaft, to the flat on the motor shaft, like so. So now I can go and install the rocker arms. So here's one of the rocker arms. What I'm going to do is I'm just going to install one of them, the actual valve I'm working on. So you can see right now this is coupled to the exhaust valve. So I'm going to put in the rocker arm and then put in the pin. Nah. This bolt has to come out first. So now I can install the pin like so. Okay, and I can put this bolt back. I only did this like 55 times, so I don't have the process honed out. to perfection. So again, I'm just gonna check if this is lined up here so that it's parallel. Okay. So now what I need to do is I need to zero it out. So the way I zero it out, there's a mark here, and then I'm gonna turn the motor until that adjustment screw is right at the mark. So you can see that the screw here came up to the timing mark. So what I'm gonna do is turn this a little bit more, like so. Okay, so that's my zero mark. And you can instantly see what I was talking about. This rocker arm doesn't want to run on the lobe. It actually wants to run here because the camshaft is not fully seated. So what I'm going to do now is I'm going to turn on the electronics. Okay, so I need to power the Arduino. Arduino needs 12 volts, so there's positive, negative. I'll turn it on, and then this one goes into the Arduino like so, and then I connect the cable to the laptop. So on the laptop I got a serial monitor, and that serial monitor basically shows me what the actual angle is. So remember, I start from 0 position, so I'll have to plug this in. Okay, turn that on. So there's the indicator, and this is the 0. So now once it starts to rotate, I can monitor the actual cam position on the serial monitor on the computer. So I still have to use a laptop for that. And what I'm going to do now is adjust the valve, the rocker arm, so that there is 0 clearance. So I'm going to go and adjust this screw so that the rocker arm is resting on a base circle of the cam, and until I got some resistance, a little bit of resistance, and then once I have that resistance I can go further and see when the indicator starts to move. So you can see that the indicator just moved to 2 microns. So I'm going to go back and adjust it to 0. Okay, it's that sensitive. And now I can go and continue the test. So the motor is doing 200 steps on a full circle. So it's doing 0.9 degree steps basically. So we are looking at the exhaust, which opens later than the intake. So we got to go to about 90 degrees until the exhausts start to open. So you can see the cam right here, the exhaust cam, it is turning counterclockwise like this, and it's coming up slowly, and it will start to lift the rocker arm. So let me put this in the center, and I'm going to put the microphone right there. You can hear the motors running. Okay, so we are at some position right now, some kind of angular position. So if I depress the button, you can hear that the motor goes 0.9 degrees, and I can record that. So this is right now all manual. So this entire thing is manual. I go and look at the angle, the actual angle, and then I read the reading. This is in millimeters, so that's 42 microns. and so on. So I can go and do one step at a time, stop, record the lift, and assign the lift to each of the different positions. Here's the scan data and the charts for the actual scans. Number 1 cylinder is shown here. The horizontal axis is the camshaft rotational angle. The vertical axis is the valve lift. The blue curve shows the exhaust and the orange curve shows the intake valve lift. You can see here the summary. So these are the number of points, 1, 2, 3, and then this is the actual angle. So you can see it starts at 1.8, 3.6, 5.4, 7.2. So I did 200 points on a circle, and then this is the actual lift. Now when I was scanning the cams, I had a lot of small movement here shown by the indicator, but right now, because the spring is keeping the valve at the seat, you can see it actually starts rising at 34 degrees here. So that's the first load point, and that's on the exhaust side. So this is number 1. Here's number 2, 3, 4, 5, and 6. And as I toggle and scroll, you can see a slight variation between them. So I summarized them all. So these are all the intake valves, and then these are all the exhaust valves. So you can see the height between them, the total lift varies, and also the actual position. So you can see number 6 is a little bit shifted to the left here. That's probably my fault, selecting a bad point for the initial position. So finally, here's some intrinsic data. I summarized the total lift. So this is the exhaust. The average lift is 5.3 millimeters, and the range is 0.336. On the intake side, the maximum lift, the average lift is 5.65, and the range is 0.4 millimeters. So it's just tolerances. I also summarized the angles where the opening, the closing occurs, and also the maximum value when the maximum hits. You can see it's pretty consistent here on the exhaust side, at least for these 4. Finally, here's a chart where you can see some faulty data. I had to re-record some of the scans due to the exhaust getting caught on the compressor cam. So you can see when that happens, there's going to be this sudden transition here, and sometimes you're going to see curves like that. So that's not good. So that's why I went back and I re-recorded the data. So that is my new cam scanner. I hope you guys enjoyed the video. If you like the video, please give me a thumbs up, and if you like the channel, please don't forget to subscribe. See you next time. Bye.